Our next non-conventional source of energy or alternative source of energy is nuclear power. Okay, so nuclear power, as you know, is obtained from energy stored in the nuclei of atoms of naturally occurring radioactive elements like uranium, thorium, and plutonium. Please remember that they are energy stored in the nuclei of atoms of naturally occurring radioactive elements, uranium, thorium, and plutonium. Now, how do you generate electricity through nuclear energy, nuclear power? So when atoms of these radioactive substances, when they react, they split apart. And this process of splitting of atoms is called nuclear fission. Okay, so when the atoms of these nuclear power, all right, it splits up, they react. And this process of splitting of atoms is called nuclear fission. Now, when nuclear fission takes place, a lot of heat is produced, and this heat is used to heat water and make steam. And it is the steam that helps to turn the turbine. So, the steam powers turbines, which in turn are used to run generators which produce electricity. So, when this nuclear fission takes place, when atoms breaks up into different particles, a lot of heat is given out, and this heat is used to heat water as well as make steam, and the steam in turn powers turbines which produces electricity. Now there are two main types of nuclear reactors used to generate electricity. One is PWR, or pressurized water reactors, and the other is BWR, boiling water reactors. Please remember, two main types of nuclear reactors used to generate electricity. One is pressurized water reactors and the other is boiling water reactors. Now, in the pressurized water reactor process, the water is heated by nuclear reaction, but it does not boil because it is under great pressure. So, this heated water is circulated through tubes in steam generators, allowing the water in the steam generator to turn the steam, which then turns the turbine and generates electricity. Now, in the boiling water reactor or BWR, the water comes to a boil due to the heat produced by nuclear reaction and turns into steam to turn the turbine. The water from the reactor powers the turbines. So in both the systems, water is reused. There is no wastage of water. Please remember, in both the systems of nuclear power, water is reused. So nuclear power is the fourth largest source of electricity in India after thermal, hydroelectricity, and renewable source of electricity. India has 21 nuclear reactors and 7 nuclear power plants. 21 nuclear reactors are like either you have pressurized water reactors or boiling water reactors, either PWR, BWR. We're talking about nuclear reactors and in operation, and 7 nuclear power plants. Uranium and thorium are available in Jharkhand and Aravalli range of Rajasthan. They're used to generate atomic or nuclear power. So the raw material, the raw material for nuclear power is uranium, thorium, and plutonium. These are the raw materials that you require for nuclear energy. Then you also have monazite sands of Kerala is also rich in thorium. So as a result, by 2050, India is aiming to supply 25% of electricity through nuclear power. Now, advantages: nuclear energy reduces the requirement of fossil fuels and thereby reduces the greenhouse gas effects. Since you're not using coal and petroleum, there will be less greenhouse gas in the atmosphere. Then fission of one atom of uranium, when there is fission, the nuclear fission takes place, one atom of uranium produces 10 million times of energy than carbon. than burning of one atom of carbon. Okay, in this way, nuclear energy not only saves raw materials but also it saves cost in transport, handling, and extraction of nuclear fuel. Nuclear energy is also the most reliable source of energy as it can be obtained 24/7. And besides, a nuclear plant also needs to refuel every 18 to 24 months. It does not need to be refueled every now and then like petroleum and natural gas. So it there also you are saving some amount of money. Now the last type of non-conventional source of energy is biogas. It is composed of methane, carbon dioxide, hydrogen, and hydrogen sulfide. Now, this biogas is produced by anaerobic degradation of animal and plant waste in the presence of water. So, what is meant by anaerobic degradation? It is breaking down of organic matter by bacteria in the absence of oxygen. So the fermentation of the waste products is carried out by bacteria. Bacteria helps to ferment the waste products and in turn produces a hydrocarbon gas like methane and alcohol. And the residue left behind in the tank can be used as manure in the agricultural field. So gobar gas plants we call, gobar gas plants are plants which use cattle dung. These plants using cattle dung have been set up in many villages and they provide two benefits to the farmers. One, in the form of energy, and second, in the good quality manure. Got it? So, gobar gas plants are very common in rural India because it benefits the farmers in two ways. One, it generates electricity, and the other, it provides good quality manure. Now, the gas which is produced can be used for cooking, lighting, and pumping water from the wells. Now, as you can see from the picture here, you have a digester tank is placed underground here. This is a digester tank. Now, the digester tank receives dung mixture, dung and water. Dung is mixed with water through the inlet. This is the inlet pipe. And on the other side, you have your discharge, the spent slurry, which we call, or the residue, through outlet pipe. So this here, the digester tank has two pipes. One is inlet pipe through which your dung and water, mixture of dung and water is put through this, and here you have the residue outlet pipe through which the residues come, and this residue, which is called the spent slurry, can be used as manure. All right, and through this here the biogas collects here, and here the biogas collects, and again the outlet to the biogas is from here. And from here, as the gas comes out, you can use it for your cooking purpose, lighting, pumping water, or for any other purpose. Okay, so waste recycling and resources recovery programs, which we call WRRSE, are now being used from the organic plant waste as well as night soil. The sewage that that is there. So sewage is also processed to form biogas, not only organic plant waste and animal waste. Biogas nowadays is not only produced through animal and plant waste but also through sewage. Now this helps in improving the sanitary conditions in our cities and villages. So this, when you're using sewage, you are reducing the sanitation problems in the cities and villages. So the plants generate enriched organic manure useful for supplementing chemical fertilizers. So the slurry that is spent here, that is given out once the biogas is produced, this is an organic manure. It can substitute for chemical fertilizers. Now, what are the advantages of a biogas? It is a clean, non-polluting and cheap form of source of energy. and there is direct supply of gas from the plant, so there is no storage problem. You don't need any storage to keep the gas. Once the gas is produced, it is used directly. And the sludge, the slurry, that is the residue left behind, provides a rich fertilizer containing bacterial biomass. All right, organic manure. It provides rich organic manure.